And welcome back to my channel. I bought this mic for my PC and it doesn't work. So let's tear it down and look at the circuit and see if we can modify it to work with my PC. I bought this microphone and it's not very good, so I thought I need to up the gain, as the gain coming out of it is very low. So I thought we could have a look and see what's inside it. Also, by taking a video, it makes it easy for me to remember how it goes back together. So we have a board, we have two boards. Two boards that look identical, but one's got no components. So maybe that's just to kind of strengthen it up. How can we zoom in? Is it still in focus? So there's the one board. It looks like three transistors, possibly four, whatever that is up there. So we're going to have to reverse engineer that, because what I want to do is I want to try and up the gain. So at least this way we have an unpopulated board. Stop rolling around. Now the focus is gone. Let's go back on auto. There we go. So let's take this one board off so we can have a quick look. Didn't think it would come apart so easily. Right. As I suspected, I've got a clean board in which to play with, so I can keep that one as is and populate this one as I see fit. So good job. So let's get on and reverse engineer this board. For those playing along at home, here's a picture of the board. Focus could have been better, but I was trying to get the light out of it, and a picture of the backside, so that if you want, you can have a go at reverse engineering the board, and we'll see what happens in a minute. Sometime later. Right, after a lot of head scratching and drawing on pictures, I finally came down to what the circuit is. It is confusing, but it is wired up as a standard XLR3 microphone with one ground and two signals. The confusing thing is the way that they use it, and actually this input or their outputs and inputs are shorted in the plug. Power can be fed into both of these, and you need at least 20 volts or so. So basically you've got two stages, and these are effectively modulating the current flowing into the circuit, and they're modulated by these two signals that come down here. But also they provide current down here to this circuit here, which is a voltage regulator. And the reason it won't work with my PC is my PC only puts out a few volts on its mic lines, and you come down here and you look, and it's got a 9.1 volt Zener. So this power supply point here will not stabilize until you've got well above 9.1 volts coming in here. So this circuit will never work with a PC unless you put it through some form of mixer to provide the phantom power. But I haven't got one, so basically this circuit is going to be kaput. It's going to go. Whether I use some of the components, I don't know. Probably some of the capacitors maybe, and some of the resistors. So we move on down to the front end then. So down here we have a condenser microphone, which as the sound comes in produces a voltage. This voltage is fed to the gate of this N-channel JFET, which then of course produces an amplified signal here. Now this is fed through to Q2, and Q2 is basically a phase splitting amplifier. So we've got the emitter resistor of 2K2, a collector resistor of 2K2. So what comes out here is exactly the same amplitude, but 180 degrees out of phase. And then on here we have a 1 mic and a 2K7, which is providing some feedback to trim the audio response of the amplifier. So these signals get fed up to here, they modulate or drive the bass, and this effectively changes the amount of current that gets fed into the circuit. And at the other end you would have a power supply with a resistive load powering these points, and then the capacitor to your amplifier to pick off the audio as this current changes in phase, or not in phase, but as it changes, as the speech changes, current through the external resistor changes, therefore the voltage changes, and that's your microphone signal. So it just goes to show this is a very, very common circuit. Once I found it, I then found on the internet that there are versions of this circuit out there, so they've just copied it, and rather than using the 2 phases, they've just shorted one to down to ground, probably to just lower the noise, or you could have just left that floating, it wouldn't have done a lot, I don't think. So that's the circuit. Now what I'm going to do is I'm going to keep the microphone, the JFET, the resistor, and I'm going to throw away this lot and build a little preamp to go in here, modify this circuit so that I can have, say, a 3.2 volt battery in here, or maybe a 9 volt battery in here, and I'll modify it so that the ground of the battery goes into one pin, the output comes out on the other pin, and the ground's on this pin. So effectively when I plug in the shorted plug, it will short the battery negative to ground, thus powering the amplifier. So the connector for the time being will be the switch, and I'll just have to remember to take the connector out, well, when I don't want to use the microphone. So that's the end of this video, and there will be a part 2 showing the new circuit, and I'll link that in with one of my experimenters episodes. So catch you on the next one.